Hey everyone, welcome to our final video on lab equipment. I'm your host Bharath, and today we'll be covering soldering. We already learned about the solderless breadboard, which allows you to connect components temporarily in order to test circuits. But what if you need to connect components on a real circuit board? Soldering is a process in which two or more metal items are joined together with a molten alloy in order to hold them together while creating an electrical connection. Soldering requires, among other things, a soldering iron, a wet sponge, solder, which is a metal alloy with a low melting point, side cutters, and safety glasses. First, plug the soldering iron in for 2 to 3 minutes until it has reached the necessary temperature to melt solder, 500 to 800 Fahrenheit. Please check the solder you're using for the optimal temperature. In this video, we will not cover surface mount devices and low temperature soldering techniques. Make sure the tip of the iron and the board are cleaned and ready to go. The soldering iron tip should be wiped clean by pulling it quickly along a clean, damp sponge. The two mating metals should be free of foreign objects and liquids. If they have a film of impurities on them, apply a bit of flux to the areas to be soldered. You can use a clamp or a pair of vice grips to hold the circuit board in place, since you will need both hands while soldering, or you can lay the circuit board out on the table. However, please be careful not to burn anything though. Before you start, please make sure there is adequate ventilation and do not breathe in the solder fumes. Apply a tiny bit of solder to the tip of your iron. This is called tinning and helps to transfer heat to the joint as well as protect your tip from oxidizing. To solder, the process goes like this. Place the component, apply heat, apply solder, and then remove the heat. I'll demonstrate by connecting this resistor to this circuit board. First, bend the leads of the component in order to fit it into the board. Push it through and then bend the leads again at about a 45-degree angle in order to hold it in place. Now take your iron in one hand, apply heat to the joint for a couple of seconds, and then briefly apply solder, not to the soldering tip, but to the mating surfaces with the other hand. It may take some practice to heat up the mating surfaces sufficiently to melt the solder, but not overheat the devices. After the solder melts and provides a good connection, solder should flow nicely and not be a round blob. Remove the iron, but be careful not to jiggle the mating surfaces, allowing the melted solder to cool and solidify. This only takes a few seconds. Periodically wipe your iron clean on the sponge and then repeat the process on the other joints, making sure to apply heat before solder. It is best to touch the solder to the opposite side of the component lead, as it will flow towards the hot iron, ensuring that your solder will be spread across the entire connection. Once you're finished, clean the iron, turn it off, and after it is cooled off, put it away. Use side cutters to clip the excess leads, getting as close to the joint as possible but not cutting the solder joint itself. Soldering looks pretty easy, but it does require some practice and attention. Here are some general tips. Do not apply solder to the iron first and then try to scrape it off on the joint. This will not make a reliable connection. Make sure to hold the component steady until the solder dries completely. If the component moves before the solder is dry, you will get what's called a cold joint, which does not allow good electrical contact and could prevent your circuit from working properly. Cold joints look grainy, dull gray, rounded, or brittle. Do not let excess solder connect two joints on the board, as this may cause a short circuit. Beginner solderers tend to use too much solder and heat the joint for too long. Good joints will be smooth, compact, shiny, and have a slightly concave appearance. After your connections have cooled, it's a good idea to double check them with an ohm meter. If the joint measures more than a few tenths of an ohm, then it should be redone. If you make a mistake, don't worry, it can be easily corrected. Simply desolder the joints like this. This is what is called a desoldering tool. The way this thing works is you push the spring all the way in, and then you activate the pump, and that'll just suck out the solder. Then let's say you want to remove the excess solder at that joint. You basically heat up the joint, allowing the solder to start flowing. There you go. Lastly, if you're soldering heat-sensitive components such as ICs and transistors, attach a heat sink in order to protect the component. An easy way to do this is to use a pair of pliers. And that's it for the basics of soldering. Remember, try to work in a well-ventilated room to avoid breathing in the fumes, and be careful with the hot iron. We hope you have enjoyed these tutorials and maybe learned a thing or two in the process. Thank you.